Students, it is our next experiment of our industrial instrumentation laboratory. So this is a differential pressure transmitter by which we can measure the flow rate, level or anything by using the differential pressure of any 2 point. So here two elements are there, primary and secondary. In primary element, a orifice plate which is an obstruction element which restricts the flow. This is our orifice. Various types of restriction elements can be used: flow nozzle, pitot tube, laminar flow element or wedged element, so like this. So this is the primary element which restricts the flow, and the secondary element is shown here which senses the differential pressure. The differential pressure is created due to the orifice plate obstruction. So this is the higher side and this is our lower side as shown in the figure. So this differential pressure is sensed in the lower side, right? Here a diaphragm, sealed diaphragm is there which senses the pressure difference of these 2 points and which is our differential pressure and gives the differential pressure output. And this is further processed, and various components like differential capacitors, strain gauges like this are used to get the electrical output, and this further amplifies and we get the amplified output, and which is used for our controlling measurement in terms of 4 to 20 milliampere current signal, right? In various cases we can get 0 to 5 and 0 to 10 volt also. So these two things are linearly relatable. Scaling depends upon the process condition as it is shown here. From 0 to suppose 100 psi the range of the differential pressure is there. So for that 4 to 20 milliampere current signal is scaled such that it is linear throughout the measurement. Suppose for 50 psi it should show 12 milliampere. Likewise it is calibrated and we will get the output as 4 to 20 milliampere current signal. This is the scaled output which is linear, right? So differential pressure transmitter acts or it works depending upon the differential pressure of 2 points. So it is used widely for measuring level and flow of any fluid, right? In fluid line it is situated like this. This is the arrangement. So here you can see a orifice plate is situated in between the flow line, and there is a concentric path where the fluid restricts and for which a differential pressure is created. So one point for measurement is before the orifice plate and another point is after the orifice plate in the flow line. So from whenever the fluid flows, there is a pressure difference whenever this fluid passes through the orifice plate, and it creates a pressure difference or pressure drop in between those 2 points, which is sensed further. The pressure difference is sensed further by the diaphragm element which is in the DPT, which is mounted in the DPT. Inside that DPT this diaphragm element is mounted and it senses the differential pressure accordingly. As per Bernoulli's theorem, it is the speed of fluid and the flow rate these things are directly dependent upon each other. So we can easily find out the flow rate also using the differential pressure. So accordingly this differential pressure is sensed by the diaphragm element, and after this differential pressure whatever we get from the diaphragm, it is further processed and we get the electrical output. So easily from this arrangement we can determine the liquid flow rate, or we can also find out the liquid level of any tank or something else. So basically you can see the operating principle, how the differential pressure transmitter actually works in the industry on any flow lines. One side of the sensing element or obstruction element will be the higher side, and the another side is lower side. So accordingly we can determine the differential pressure, and using the differential pressure we can find out other parameters also. Thank you.
So students, today is our next experiment, which is differential pressure transmitter. As the name suggests, differential pressure transmitter means we have to measure the difference in pressure in between 2 points. In industrial aspects, there are very wide application of differential pressure transmitter, as it is used to measure the flow rate, measure the level of any fluid, or various applications are there of differential pressure transmitter. So today we will measure the pressure difference of 2 points using this differential pressure transmitter. So this is our DPT. You can see there is the connection, positive, negative and ground, and here a check point is given, which is used at the time of calibration purpose, right? So it requires a supply of 24 volt DC basically, and in industrial applications, whenever we will measure the pressure difference, it will be processed and will be conditioned and amplified, and we will get electrical signal, and for this purpose the measurement is done within the range of 4 to 20 milliampere current signal, and in some applications it may be used 0 to 5 volt or 0 to 10 volts also. So here you can see 2 points are there, these 2 points. In these 2 points, 2 air filter regulator is used. Air filter regulator means you can regulate the pressure and it will filtrate the air or whatever gas or air you are passing. So in this instrument there is 2 points, high or low, 2 sides are there, because whenever a pressure drop will be created in this line, it will be measured by this DPT. So high side and low side, the difference between these 2 sides will be measured and processed. After processing we will get the electrical output, and it will show the flow rate in mmH2, or else in different applications units may be differ. Okay, so in practical industrial purpose there will be already a pressure in any flow line or any pipe. So actually you have to give or apply pressure using compressor. So in this laboratory we are just demonstrating you, or will make you understand that how it works. So we are not going to use any compressor is not there now, so we will just show you how it works. Whenever the pressure is applied in either side of these 2 points, we will get a differential pressure, or a differential pressure will created in this between high and low side, right? So after that this pressure drop will be sensed by a diaphragm element which is situated in this pressure transmitter. This diaphragm will be deviated slightly according to the pressure drop, and this diaphragm will sense the pressure drop, and this will be further processed in terms of electrical signal. We will get the output here. So various components are used to condition or amplification of this PSI or bar or whatever pressure. In terms of pressure unit you are getting the physical quantity as pressure, and the electrical signal will get here. So basically the pressure difference will show you the reading here in the unit of pressure unit, and the signal we will going to take from this in terms of 4 to 20 milliampere unit. Okay, and it will be further used for controlling purpose or whatever in the control system or the panel. It will require a electrical signal, that's why 4 to 20 milliampere electrical signal will be used. So it will be a linear. Suppose your pressure delta P range is 0 to 100 psi, suppose. So for this 0 to 100 psi pressure range, the output will be 4 to 20 milliampere. That means for 0 psi pressure you will get 4 milliampere output, and for 100 psi pressure you will get 20 milliampere output, and in between this, for suppose 50 psi pressure drop, you will get pressure drop, not exact pressure of any point, pressure drop between two points, right? So for 50 psi you will get 12 milliampere current signal. So likewise it is divided into this type of linear scale, right? So this is the procedure we will show you. Basically we cannot apply any compressor or apply any pressure using compressor externally. So as we know, pressure is nothing but H rho G. According to this we can determine the pressure. So these 2 points are of same height now. So we will first turn on this instrument, and now you can see, now you can see the instrument has turned on. This is showing 0. So here these 2 points are of same height. So if we change the heights of either of the point according to H rho G, the pressure will slightly change. I repeat, this is not the standard procedure to determine the differential pressure. We are just demonstrating you how it works. That's why we are to create the pressure difference slightly, we are just tilting this. So whenever I will tilt this one, this is will be a higher point, or this will be a that means there will be a height difference of these 2 points. Accordingly pressure will change, and you can see the output, it is showing like 1 mm/2, right? So again you will increase, if you increase the height more, it is showing 2, further increase it will show 3. So likewise, as the height changes of these 2 points, according to the difference in height of these 2 points, the output, that means the differential pressure, is also changing. But this is not practical practice, we are just demonstrating how the pressure difference is measuring here. So due to this change in pressure, which is measured by this instrument, this pressure drop is sensed by the diaphragm element, which is situated in between this, and further it is processed using maybe a strain gauge or any other electrical component, which is further processed and amplified, and we will get the output as 4 to 20 milliampere current signal, right? So this is the whole procedure of differential pressure transmitter. Okay, so guys, you just go through this video or demonstration, whichever is explained in this video. Just go through this, and if you have any doubt, you can ask me anytime, and accordingly you do your tasks as explained in your previous experiments also, right? So thank you.